So in this question, given P is a singular matrix. P is a singular matrix of 3 cross 3. So therefore it will have 3 roots. But already given in the problem root 3 plus root minus 1, that is nothing but given already 3 plus or minus I. 2 roots are given. But actually to find determinant of P, we know already the product of eigenvalues is equivalent to det P. So det P is equal to the product of eigenvalues. Product of eigenvalues. But given in the problem only 2 roots are given. So remaining root is required. But already given a condition singular matrix. If P is singular, then implies one of eigenvalues is 0. One of eigenvalue is 0. It is compulsory condition as per singular matrix condition. Therefore, determinant of P is equal to the product of eigenvalues. One is 0. The one other root is given in the problem, and second root is 3 minus I. The product of these 3 roots equivalent to 0. Therefore, determinant of given matrix is P, 0. So in this question, we need order and degree of the given differential equation, that is d cube x by dt cube is equal to 2 plus d square x by dt square whole to the power of 3 and whole power 2 by 3. In this differential equation, we need order and degree. But to find the order and degree, first of all, we have to make the given differential equation powers are free from radicals and rationals. That is, radicals means you are given already 2 by 3 is a radical. Once if it is radical, we enable write directly degree and order. First make them free from that. So how to make this free from the radical? Both sides if you cube, then automatically the right side power will become as an integer. That is differential equation. If it is consisting of powers or integers, then only we can decide order and degree. So therefore, if you cube both sides, dt cube whole to the power of, here already 3 is there, 2 by 3 is there. To cancel the rational number, both sides cube it. So 2 plus d square x by dt square whole to the power of 3, and it is 2 by 3, cube it both sides. So therefore automatically the rational will be cancelled. That is nothing but we are making the powers of this from the radicals to integers. So therefore left side we are getting d cube x by dt cube whole to the power of 3 is equal to, again it is in the form of a plus b whole square by cancellation of this one and square this one. So we get a square plus d square x by dt square already whole square is there, again by squaring this one to the power of 6 plus d square x by dt square whole to the power of 3 whole square. Already I wrote this one. 2ab, 2 times of 2 into d square x by dt square whole cube. Now all the powers of derivatives are free from radicals and rationals. So therefore now we can decide order and degree of the differential equation. Order means the order of highest derivative. Order of highest derivative means here second order. It is also second order, but it is third order. Therefore, order of this differential equation is 3. And the degree is the power of highest derivative. But what is the power of highest derivative? Actually, we are having power is highest, but it is second order, and here also we are having third power, but in these two we are having only second order, but third order power is 3. Therefore, your degree of this differential equation equivalent to 3. So order is also 3, degree also 3. The question is in the form of m dx plus n dy is equal to 0. To find an integrating factor, we have different method of integrating factors. Depends on the conditions of m and n. So here dou m by dou y. Dou m by dou y is x and dou n by dou x is equal to 4x. So dou m by dou y is not equivalent to dou n by dou x. What is the meaning of dou m by dou y not equal to dou n by dou x? It is nothing but the given differential equation is not an exact, and it can be reduced to exact form by multiplying with a integrating factor. That integrating factor can be evaluated in different methods. So here dou m by dou y minus dou n by dou x is equal to x minus 4x, that is equal to minus 3x. So therefore, the value of dou m by dou y minus dou n by dou x is equal to minus 3x. By dividing either m or n, we have to check first condition. If it is divided by m, then we need only function of y. By dividing with n, we need only function of x alone. But comparing m and just observe these two here. So if you divide this value with m is xy is equal to, here I am just replacing xy. So we are getting minus 3 by y. It is equivalent to g of y, that is function of y alone. Function of y alone. So once if we get function of y alone, then we can find integrating factor by using this method. So therefore integrating factor is equal to e to the power of minus g of y dy. So e to the power of minus, already g of y is equal to, we have minus 3 by y dy. Integral of 3 by y dy. But what is integral of 3 by y? 3 log y is equal to e to the power of log y cube. It is equivalent to y cube. So integrating factor is y cube. Okay, here limit of 2n power 4 all to the power of 1 by 3n as n tends to infinity. Generally in some limits we can apply directly limit concept, but if you apply limit concept here, n tends to infinity, we are getting inside of the bracket is as tends to infinite and power is 1 by infinite. Approximately it is infinite to the power of 0 is giving, but infinite to the power of 0 is indeterminate form. Once if it is indeterminate form, then we are unable to apply directly limit concept, indeterminate form. So in this case we have to make that into determination form by using various methods, either factorization method or standard formulas or L'Hospital rule. So before applying that condition, just I am taking as this is equal to y. If you consider this is y, apply both sides log. Apply both sides logarithmic application. So therefore log y is equal to limit as n tends to infinity. You can apply logarithmic either outside or inside. It is a limit concept. So therefore we are applying that one. So log 2n power 4 whole power 1 by 3n. So that is equivalent to limit n tends to infinity. So log m power n formula. Log m power n formula is n log m. So this is log y. Now also if you apply limit directly, then we are getting log infinite, that is undefined case. So undefined by undefined, it is also indeterminate form. Again we are getting indeterminate form in a form of infinite by infinite. So we are unable to apply again limit directly. So that if you apply any other factorization or any concept, it can be possible. So here I am applying directly L'Hospital rule. So if you apply L'Hospital rule, what is L'Hospital rule here? L'Hospital rule means apply both numerator and differentiation, that is both numerator and denominator differentiate, and after that if you get determination form, then only you can apply limit. Again if you get again indeterminate forms, then again once again apply limit as n tends to infinity by using L'Hospital rule. So first L'Hospital means numerator. What is numerator here? Log 2 to the power 2n power 4. So differentiation of this is log x is 1 by x into again inside differentiation of this one, that is a chain rule of differentiation. So it is 8n cube. It is a numerator and differentiate denominator. So the derivative of 3n is 3. The derivative of 3n is 3. So if you cancel this n cube and n power 4, the remaining is limit n tends to infinity 8 by 2n, that is 4 by n. Now if you apply n tends to infinity, we are getting directly determinant form, that is 4 by undefined condition becomes as 0. But left side is not y, our requirement is y. So therefore log y is equal to 0, but for what value of y we get 0? Only for 1 as per log condition. So y is equal to 1, it is our option. Okay, in this question, our requirement is a line integral around c sin of x cube dx plus 6xy dy. But where c is given the path consisting of a triangular path with vertices 0, 0 and 0, 2 and 2, 2. Actually, line integral always we follow anti-clockwise direction. That's why I have given here the path direction is in the counterclockwise direction or anti-clockwise direction. So we have to find line integral along with three paths, that is OA and AB and BO. It consisting of three paths, but it takes more time to calculate line integral along with three paths. That's why it can be converted into other integration. That is, by using Green's theorem, we can convert into double integral. That is, Green's theorem states the relation between line integral and a double integral. So that is equivalent to double integral over R, the region, and dou m by dou. Okay, I will write the theorem later. So here dou n by dou x minus dou m by dou y dx dy. And what is n and what is m here? It is m, it is n. That is integral m dx plus n dy is equal to double integral over r dou n by dou x minus dou m by dou y dx dy. So that is equivalent to double integral conditions. Double integral conditions, as per this condition, we have to first fix any one of two variables is as constant, either maybe x or maybe y. So I am fixing constant x value. X value is in between 0 to 2. X value is in between 0 to 2. Therefore, x takes from 0 to 2 condition. And y value, lower limit is not the constant. It is along with this line. So therefore, lower limit is x to 2, x to 2, x to 2. So I am taking lower limit y is equal to x to 2. And dou n by dou x, it is n with respect to differentiation 6y minus dou m by dou y. Dou m by dou y, but in this one there is no y variable, therefore it becomes 0. Dx dy. So that is equivalent to integral x is equal to 0 to 2, y is equal to x to 2, d6y dy dx. The order of integration depends on the limits. First your y limits are variables. That's why first integrate only with respect to y. So that is equivalent to integral x value 0 to 2 and differential integration of y is y square by 2. The limits are x to 2 with respect to x. So that is equivalent to integral x 0 to 2 and 6 upper limit value x y square by 2. So upper limit is y square, that is 4. 4 by 2 is 2 minus lower limit y value is x, therefore x square by 2 dx. Now again integrate with respect to one variable. So 6 2 integration is 2x, x square by 2 is x cube by 6, because already denominator 2 is there, so that is x cube by 6, 0 to 2. So therefore by simplification of this it gives 16. Just apply upper limit and lower limit value. So in this question, the complete solution of the ordinary differential equation of d square f y by dx square plus a minus 1 into dy by dx plus by is equal to 0. It is given as y is equal to c1 e power minus 2x plus c2 e power minus 3x. Then the value of arbitrary constants a and b. So here complete solution means that is particular integral and complementary function summation. But your right side 0 is given, so complementary function becomes as complete solution. But already given complementary function as c1 e power minus 2x plus c2 e power minus 3x. As per this one, the roots of auxiliary equations we get m is equal to minus 2 and m is equal to minus 3. So the roots of auxiliary equations are minus 2 and minus 3 means the differential equation of the consisting of these roots is d plus 2 into d plus 3 of y is equal to 0. So therefore d square plus 5d plus 6 of y is equal to 0. So that is nothing but here d square y by dx square plus 5 into dy by dx plus 6y is equal to 0. Given equation is in arbitrary constants, but as per the complete solution we are getting the differential equation is this one. By comparing these two equations, here we get a minus 1 is equal to 5, that implies a is equal to 6, and here b is equal to 6. So our values of a is 6 and b is equal to 6 by comparison of these two equations.